Hello, and welcome to the Amazon Web Services Partner Webinar Series. Our topic today features Move Microsoft Exchange to the AWS Cloud. I'm your host, Sherry Sullivan. I'm here with the partner marketing team in Seattle, and I'd like to start with just a couple housekeeping items before we begin. I'd like to encourage folks to submit your questions anytime during this webcast using the Q&A manager in your browser. I'd also like to remind folks we do make this content available on the AWS SlideShare channel as well as AWS YouTube channel. Today we'll cover an Amazon Web Services overview and customer benefits. We'll lead into our partners with Smartronix sharing why Microsoft Exchange on AWS, planning and testing for migration, a customer use case, as well as some next steps to get started. And we'll finish off the webcast with some time for Q&A. I'm very pleased today to be joined by our premier partner, consulting partner, Smartronix, along with Ulf Schuh, who is a solutions architect focused on Microsoft solutions here at AWS. I'm pleased to present, we have Robert Grote, who's the CTO of Smartronix, Kevin Brown, who's a senior solution architect with Smartronix, and Anthony Voltaggio, who is the deputy CTO of Smartronix. So with that, I'd like to turn it over to you, Ulf, to take it away.
Thank you very much, Sherry. Good morning, everyone. I wanted to take a couple of minutes at the beginning of this webinar to set the stage for the presentation that you're going to hear from Smartronix about how to actually deploy and some of the considerations you have to put into play when putting Exchange into production in the AWS cloud. So one of the many questions we've received from other partners and customers is how are enterprise actually using AWS today? And we see three major use cases here. They augment on-premise resources with cloud-based capacity. In many cases, customers and partners approach us and say, look, our data centers today are at their maximum capacity. We can't build out, or building out the existing data centers would require an extensive investment in capital expenditure, or just simply they want to set up a completely new environment and do this so that the existing production environment in their on-premise data centers are not impacted. The second use case we see is migrating existing apps to the cloud, just as a strategic decision the customer makes in order to gain greater agility, to reap in the cost savings that come with it, and many other benefits we discussed throughout these presentations. And last but not least, enterprise customers move to AWS and use AWS in order to build new applications, new sites, completely new services, taking cloud patterns and benefiting from the inherent elasticity that the cloud provides, the sheer endless scale that a cloud platform offers. And so these three use cases are the predominant ones that we're seeing, and as we're discussing further on, Exchange in particular, you find some of those reflected in there. As a quick overview, just for a level set, what is AWS? AWS is a set of services that at the core consists of compute, storage, and databases, and is augmented by networking, application services, and deployment and administration built on a global infrastructure. Speaking about global infrastructure, the AWS global infrastructure today exists in 9 regions around the world with 25 availability zones. In the context of talking about Exchange, you can think about availability zones as distinct data centers that are regionally separate and in completely separate locations. And we are continuously expanding to be closer to where our customers are and where our customers want us to be. To give you a sense of the scale of Amazon's web services, if you look back to 2003 at Amazon.com, an already successful 5.2 billion retail business with 7,800 employees worldwide and a whole bunch of servers, and we fast forward to 2013, then we see, and I can tell you that every day AWS adds enough resources and server capacity to serve this business every single day. Just let this sink for a minute to get a sense for the scale and the scope that we are talking about with regards to the available infrastructure. Amazon today serves a whole lot of customers from all walks of life and for all sorts of businesses, from oil and gas industry to the news media to medical and R&D to gaming companies and to the government. The customers that take advantage of the AWS services we find in all segments around the world. And these customers, obviously, as they come from so many different types of business, have all very unique requirements around the security that a cloud-based infrastructure needs to fulfill. And AWS serves these customers by ensuring that the underlying infrastructure meets the relevant security requirements, as you can see here, from FISMA over ISO, over SOC, over FIPS, and others, in order to provide a secure platform for any and all enterprise workloads. So to sum it up, why do enterprises choose AWS today? There are 6 key benefits, and we will see them reflected in the next couple of over the next half hour in the presentation from Smartronix. The general benefits of cloud computing, we talk about no upfront capital expenses. All you need is your credit card, sign up for an account, and provision resources as you need them, as you want to use them. All that at the lowest possible cost at a pay-as-you-use, whatever you use, in that kind of model. The infrastructure as such is completely self-service. Scale out at any time as your business and your specific situation requires. This overall leads to great agility and time to market with your applications. And we want to take now a look at how one of our partners, Smartronix, is helping actually our joint customers move enterprise workloads like Microsoft Exchange, which is one of the most mission-critical messaging platforms in the enterprise today, to the AWS cloud. And with that, I'd like to hand over to our partner, Smartronix.
Thank you, Ulf. This is Robert Grote. I'm the CTO of Smartronix. Thank you and AWS for sponsoring this, and thanks to the many people taking time out of their busy day today to attend this webinar. As Ulf had mentioned, many enterprises are implementing critical business workloads on AWS, and we're excited about describing how you can move Microsoft workloads like Exchange onto this platform. Promise to keep the sales talk to a minimum, and I'll get right to the heart of the discussion, talk a little bit about a quick background on Smartronix. We were founded in 1995. We're a $100 million plus company. We specialize in very large network operations, cybersecurity, infrastructure services, and enterprise application development and deployment. We design, deploy, manage, and secure some of the world's most complex and largest networks. We've been a consulting partner with Amazon since 2009. Last year, we were awarded one of the premier consulting partnerships. We're an authorized government partner, a channel resale partner, and a Microsoft certified gold partner. On top of that, we offer 24/7 by 365 managed AWS services. With regard to Exchange, we've been involved in Exchange migrations, upgrades, and management of some of the largest Exchange deployments in the world, including hundreds of thousands of users. We currently operate and manage over 30 large-scale, high-volume websites running on AWS. So when we look at IT deployments, there's 7 criteria that we really measure the success of IT. The top 4 are basically service requirements, and the bottom 3 are platform requirements. At the end of this presentation, we're going to revisit these in the context of our case study where we deployed Exchange on AWS for one of our customers. The 7 areas that we look at is how reliable and available is the solution, how well does it perform, does it scale effectively, is it secure, was it delivered at a low cost, was it quickly delivered, and one that a lot of people fail to look at is the operational effectiveness, and that basically entails what is the burden to operate and maintain the solution going forward. So in general, why are people deploying Exchange on AWS? Well, obviously mail is still a critical collaboration tool. Outages are unacceptable, loss of data is unacceptable, and for a lot of organizations, control is very important. So when we're looking at primary drivers for why enterprises are considering Exchange on AWS, a lot of them have delayed upgrading their on-premises environment, either due to CapEx purchases or limitations within their own data centers. And frankly, many enterprises aren't ready to go to a third-party SaaS provider for such a mission-critical application. They've made the decision to kind of manage and control the messaging application themselves, and they just want more reliability and a lower-cost infrastructure to support them. So with AWS, we're seeing that there's more resiliency at a lower cost, and there's a seamless path for transitioning, migration, and upgrading of their solution. In this next section, we're going to talk about a particular case study, and here was the customer requirements. Basically, they had a decaying and kind of costly single data center with on-prem hardware, but their scenario wasn't just implementing in a greenfield environment. They wanted to transition and upgrade and do a migration. So they wanted to move from their Exchange 2007 environment on physical hardware on premises to Exchange 2010 on AWS. Their goals were they wanted to remove any single point of failure. They wanted to have fault tolerance at the data center level. They wanted to minimize or effectively eliminate any transition downtime. They wanted to integrate their services with both Link and SharePoint, and their requirement was to support about 500 mailboxes. With that, I'm going to turn it over to the solution architect that implemented the solution for them, Kevin Brown. Kevin's going to walk you through sort of the planning approach, deployment migration strategies, and architecture for our solution.
Hello, this is Kevin Brown. Designing your deployment for Exchange on AWS, it's the same process as though you were designing it for physical on-premises hardware. You use the same tools, the same migration process. In this case, you just go through the Microsoft Role Requirements Calculator, develop your candidate design for your anticipated user workload and usage scenarios. Then you go in and you take a look at what AWS has to offer as far as the instance types, the network services and such within VPC, and you treat your availability zones as just separate logical data centers. And you use the different services that are available to spread your workload across those availability zones to insulate them from a single data center failure. In this particular case, when you're doing this planning, you need to take into account the different instance types that are available from Amazon, the difference between an elastic compute unit versus dedicated physical cores, the memory sizing for what's available in each instance type as far as memory is concerned. When you're looking at the storage, your EBS volumes, the standard IOPS versus the other offerings that are available to you, such as optimized and provisioned IOPS, the network design for your VPC, whether or not you're going to be routing your internal client traffic across the VPC VPN or have everyone go out the internet and come back into your service entry point at AWS. Your service load balancing, at this time Elastic load balancers aren't compatible with Exchange, but there are a variety of other third-party solutions which are detailed in the Amazon white paper for this. The whitelisting of your Elastic IP addresses for your message transport gateways, that's something that needs to be done because by default all of the Amazon IP space is actually blacklisted on Spamhaus. So that's something that you would need to do is make sure that your message transport gateways get whitelisted before sending any email. And then scaling outward instead of scaling upward, which is based on the types of users you have, the mailbox profiles that they use, as well as how many EBS volumes, which are essentially LUNs, can be attached to a given instance, and the IOPS requirement for each of those. So continuing. So you would use the Microsoft Exchange Server Deployment Assistant just as you would for any other Exchange deployment to generate your checklist for your steps, whether it's a transition or if you're just extending your existing infrastructure out to AWS, or if you plan to do it, or if you actually plan to do a coexistence model followed by a cutover. Use your standard tools to validate your candidate designs that you produce using the role requirements calculator and the other tools that are available from Microsoft. You then validate those candidate designs using jet stress against your storage system that you've set up for your EBS volumes. Make sure that you pre-initialize your EBS volumes doing a full format just as you would in any other thin provisioned environment, whether it's AWS or physical hardware. You would use the Exchange Load Generator as your last step after you have all of your Exchange role services configured to validate that your client access and your message transport are going to meet your service level requirements. And then you would execute your organization's functional test plan to validate your production deployment and follow up with continuous monitoring and maintenance using something like either Amazon CloudWatch or using an application intelligent tool such as Microsoft System Center Operations Manager with the AWS Management Pack. As far as backups, you need to consider using application-aware backup tools, tools that understand Exchange and support volume shadow copy service, which is the supported method of backing up Exchange. EBS snapshots currently don't support VSS, but they're working toward that. And then, of course, using AMIs as a method to do complete server backup so that you can rapidly reinstantiate a given instance and then restore the application data from your application-aware tool. As far as Exchange Server version transitions are concerned, as of Exchange Server 2007, as I'm sure everyone knows, in-place upgrades are no longer supported. So transitioning between Exchange Server versions requires that you provision new hardware, configure new Exchange Server installations, redirect your existing service entry points, and move mailboxes. Once you've done that, you then have all of this hardware sitting around, or virtual machines if it's a private cloud. In this case, you're looking at the procurement of new resources to support these new virtual or physical servers to facilitate the transition, and then you have all of this equipment left over, all of this capacity left over. With AWS, that's something that you don't really have to deal with because you can quickly instantiate new instances, new storage, configure your Exchange roles, move your mailboxes, go through the standard transition process, and decommission the old instances in storage and no longer be charged for them or have any responsibility for them. So this is a very simplified diagram of our customer's environment and that had the 500 mailbox scenario. They wound up just doing this with 2 mailbox servers. They decided to separate the client access and hub transport roles onto different instances. You'll notice that everything is split across 2 availability zones within the same VPC. That insulates each of those services from an individual availability zone failure. The file share witness is located on one of the hub transport CAD servers. They also have an alternate set up on the other one, and they would run the appropriate PowerShell commands in the event of needing to do a failover or a switchover. There's a domain controller in each site. There's actually more than one domain controller. Again, this is just a simplified diagram. And they also have an edge firewall and reverse proxy service in place for client access. But the main takeaway here is that everything is split across 2 availability zones, which again insulates them from a single logical data center failure. And if you preferred, you can certainly collapse the Exchange roles that you see in the diagram, the client access, hub transport, and mailbox. You could certainly use a multi-role installation. There's nothing stopping you from doing that, and Microsoft certainly does not recommend not doing that. So that's certainly a consideration that you can look at in terms of reducing the overall runtime cost. So deploying Exchange on AWS is the same process that you would use if you were going to extend your existing environment to another physical data center. In this case, you're just creating your VPC and all the associated networking elements, such as your subnets, setting up your routing as to whether or not you want to have a NAT instance or something in place to provide for secure outbound access. You launch your instances, attach the associated EBS volumes based on your design. You validate your storage again using JetStress. You install and configure your Exchange server roles. You then change over your service entry points. You then perform mailbox moves, which of course are going to be online if you're running 2007 or newer. If you're doing a transition while also moving to AWS, then if it's 2003, obviously your mailbox moves will be done offline. You add your public folder replicas, wait for the replication to finish, perform your functional testing with a few pilot user mailboxes. Then, if everything goes well, move the remainder of your user mailboxes to AWS, and then decommission your on-premises infrastructure using the Microsoft published guidance for each service to make sure that there's no disruption.
And discuss high availability. This is Anthony Voltaggio. Again, looking at the building blocks that AWS provides to build Microsoft Exchange on top of. When you look at what's available, you get the no single point of failure. You have a multi-AZ approach within a single region. You have the capability of deploying or creating backups and images of the instances that you deploy across multiple regions. So what that provides, again, is worst case scenario, you have an entire region go down. You have the capability to restore your last instance that you backed up of your Exchange environment to any region within AWS. So again, that gives you the capability to deploy, create instances, create images of those instances, and then have that availability and DR capability to go ahead and restore those instances within other AZs or regions within the AWS infrastructure. So looking at the design that Kevin had outlined, you have the domain controllers across multiple AZs, again, protecting yourself against a single AZ outage. You have the storage availability of EBS, which every instance that's deployed is mirrored to another exact copy within that region. So again, if you have a failure of that EBS volume, there's an exact copy of that volume that goes into a restore state. The storage availability, again, the availability that EBS offers, as well as the capabilities within S3 to maintain a consistent backup copy of your Exchange data, and the monitoring capabilities as far as leveraging CloudWatch and leveraging additional tools on top of that, such as System Center Operation Manager, CNOS, et cetera, to get that full visibility to your application Exchange stack. And when you look at the scalability for Exchange within AWS, again, the main approach is to scale out, not up. There are limitations within a DAG about how many members you can have. But again, once you reach that limitation, there's nothing to stop you from creating additional DAGs and scaling out. As far as security within this implementation, again, it's not much different than implementing within your own private data center. You still have your perimeter controls with security groups, the ability to put network-based ACLs, the ability to have your inline IDS and firewall capabilities, the reverse proxy configurations, the ability to implement log and auditing of the existing access controls, as well as the data protection, encrypting your Exchange mail store. That's a capability with additional tools that can be enabled within AWS, as well as the backup solutions that you implement. There's utilities that currently leverage existing AWS services, such as S3, to store your backups in, that support encryption and key management of those backups as well. So again, you can make sure that both your Exchange mail store as well as your backups that are stored within S3 are fully encrypted and keys controlled by the customer. As far as message hygiene, again, as far as putting an edge transport role, other third-party software within an AMI within AWS, you have full control and options over the different type of message hygiene solutions you want to have. And to follow up on the message hygiene as well, you have, again, the capability to implement any implementation of antivirus management or anti-malware solution.
Thanks, Anthony and Kevin. This is Rob again. So looking at the cost side of this, obviously the implementations vary, but our experience has shown a dramatic savings over traditional IT. And when you're looking at the cost of this, it's a lot different than just, considering the server-to-server cost. I mean, obviously there's a lower CapEx, but there's also lower implementation costs and moving forward operational costs within an environment like this. One of the things that a lot of people overlook is the cost of human error, and that typically is a lot more than people expect. What if you're wrong when you're doing a traditional IT planning deployment? What if you're wrong with your compute and storage estimates? Well, there's what you tend to do is you typically overbuy, and that'll end up in having excess capacity, and that isn't cost efficient. But if you underbuy, that could be even worse. You could have performance degradation, you could have procurement delays while you're waiting for the new hardware to arrive, or worse, you'll have some kind of outage or service failure. With a cloud infrastructure like AWS, you have that ability to finely tune your environment to meet your needs. In fact, one of our best practices will end up implementing a solution on maybe a higher performing environment at first, and then start to move it down. And you could really start to match the performance and expectations of your solution directly to the instance sizings that you require. And then with that, you have other costs too that a lot of people tend to not consider, and that's the power, the space, the pipe, and more importantly, the ability to actually do multiple locations. Many enterprises can't afford to have multiple data centers. Data centers are fairly costly anyhow, or in their secondary data center, if they do have it, it's typically a very minimal footprint, and they can't afford to have a lot of their mission-critical applications being able to be mirrored and run as effectively in that environment. So with AWS, you really get that ability to kind of have multi-data center or data center fault tolerance kind of baked into your solution. When you buy stuff, when you have your own private cloud, you're also continuously facing either low utilization or you're constantly in the mode of needing to add excess capacity quickly. So let's take a look at our 7 criteria for success and kind of describe how the AWS infrastructure supported us with that. I mean, obviously, when you look at reliability, AWS has an SLA for 99.95% uptime for EC2. S3 is up to 11 nines for durability. But beyond just the AWS infrastructure, we removed single points of failure by looking at stretching our identity management solution across data centers. We looked at the database availability groups being stretched across data centers as well. So we could actually use those building blocks of AWS to increase our SLA back to our customer. Responsiveness. Obviously, you can finely tune your performance across any amount of configurable compute or storage and network. Scalable. As Anthony had mentioned, scale outward, not upward. You have the ability to increase storage or capacity as needed. Highly secure. Obviously, security is a #1 priority. By having a Exchange infrastructure that you have full control, you can add your own security requirements to it. You can add your own applications to support it. You have a lot more control above the hypervisor for your solution. Lower cost. Again, you're able to minimize waste by matching performance. You're able to reduce the CapEx. In the case of our customer, there was a minimal CapEx, but that was just for the reserved instance purchasing to lower their monthly cost. And there's obviously lower operational cost and lower labor cost associated with it as well. Agility is a key component also, and one of the things that really drives innovation on the platform. This project finished in the time that it would typically take to procure and configure hardware on premises. And then operational effectiveness, removing that burden of undifferentiated heavy lifting. Your business probably succeeds because of the unique value that you offer to the market. Focus your resources on increasing that value and let the undifferentiated heavy lifting associated with commodity IT services really to be handled by one of the world's largest infrastructure service providers. So some of the best practices, tips and tricks that we'd like to leave you guys with. Obviously, continuous monitoring of your environment is critical. We want you to combine some kind of monitoring tool, either using SCOM is what we typically use with the Amazon CloudWatch or with the AWS Management Pack. When you're doing your when you're looking at your monitoring tools and jet stress and getting performance data and everything, it really makes a lot of sense as a best practice within AWS to tag your instance volumes to make it easy to identify them in your monitoring tools. Actually, you really want to tag everything. AWS has added a lot of capabilities recently for just being able to really have much more transparency and control of your environment by having custom tags added to the infrastructure components. Obviously, a best practice, like we had mentioned, is to improve data center fault tolerance by stretching your DAGs across availability zones to insulate them from availability zone failure. Optionally, you have the ability of putting the file share witness even in a tertiary site to insulate the DAG from quorum loss in the event of an AZ failure. Other things that we recommend are configure your Outlook clients to operate in cache mode for more reliable user experience. Also, it reduces the internet bandwidth required. Configure your clients to operate in Outlook Anywhere mode. This mode has built-in support for automated service failover. Use a remote desktop gateway, Forefront UAG, to provide secure pre-authenticated access to RDP and Exchange server client access. This is a common question that we get. Looking at Exchange on premises versus Exchange in a cloud infrastructure or versus other software as a service messaging options. And really it boils down to the amount of control and integration that you require. If you have requirements for maintaining some kind of host-based security or some kind of standards compliance, and you need security agents or monitoring on those components, this gives you the control over that infrastructure because it's really you'll control all of the OS and above characteristics. If there's third-party applications, maybe you have a legacy environment that a lot of stuff has been built around your messaging infrastructure. You have third-party tools that continue to need to be supported. Obviously, by having that control over the infrastructure, you have that ability to have Exchange-integrated third-party application support. There's some other capabilities that you have in terms of applications requiring legacy public folder access. You'll have more control, more granular control over the geographic placement and partitioning of your data and services. Many of the software as a service offerings don't offer the full suite of capabilities that you could have out of an Exchange server deployment. So obviously this would give you access to the full feature set. And some require some lifting to be able to support single sign-on or hybrid deployments. And in this type of infrastructure, you can really extend your on-premises identity management environment. Your Active Directory for us and your Exchange server organization can now be self-contained and controlled in that environment. Next steps, we highly recommend that you review the white paper and CloudFormation templates that are out there. The addresses are listed below. But take a look at that. The Exchange white paper goes into a lot of detail on how to configure and manage your environment with a lot of emphasis placed on some of the unique aspects of AWS. The CloudFormation template will enable you to quickly build out an Exchange environment with a few clicks, and that's a very interesting way to be able to very rapidly test Exchange infrastructures running on AWS. If you have any questions after this for us, or you want to request a demo of how to deploy Exchange on AWS, you can mail cloudassured@smartronix.com and request a demo, or you can request planning services or any kind of design services from us through that address as well. I'd like to repeat what Sherry had said earlier. If you guys have any questions, we'd like to answer them, and if we can't get to them today, I'll personally promise you that we'll send out an email and make sure that all of your questions are answered. Sherry?
Great, thanks, Robert, and thanks to the Smartronix team, Anthony and Kevin and Ulf from AWS for a great overview of how to move Microsoft Exchange to AWS Cloud. So with that, as Rob just said, feel free to ask any questions. We've got some that are coming in already, so we'll get started with opening it up to questions. Kevin, I'm going to point this question back to you, and feel free to chime in, Robert, Anthony. At what point would you need to scale your deployment outward by adding another instance?
That's based on your user volume, the size of mailboxes that they're using, the usage profile, and how many instances you already have deployed and the size of those instances. You have to take all of those factors into consideration. There's a certain number of EBS volumes that can be attached to a given instance, and the size of that instance and whether or not it's configured as EBS optimized, as well as whether or not you're using provision IOPS, governs how many mailboxes you could actually have that single instance support. So once you've exceeded that threshold, at that point is when you would add another instance and configure it as another mailbox server within your DAG. As far as any other Exchange roles, you would just need to do monitoring on those to using something like System Center Operations Manager or another tool to take a look at whenever the service is being exhausted on that particular system, at which point you would add another instance. Most of the Exchange roles have baked-in load balancing, so that's something that's relatively easy to do.
Thanks, Kevin. The next question we have is, and I'll point this back to Smartronix team, can you implement Link and SharePoint in the AWS Cloud as well?
This is Rob Grote. Yeah, we've actually, for this particular customer, we've implemented Link, and they have a SharePoint environment also running in the AWS infrastructure. And a lot of clients, a lot of enterprises want to do that. They want to move multiple workloads in there. And one of the things that is unique about this particular client is the ability to integrate enterprise voice and remote call control. So for the Link implementation that we did with them, we integrated within AWS all of the Link front ends and mediation server, but we actually have a callback to their
PBX.
Their PBX, basically, their live business gateway that they're using to integrate, sort of have a UC model for them where their users can have presence awareness, full media, full Link, full Exchange, and SharePoint all integrated together with their enterprise voice.
Great. Thanks, Rob. Next question I'll pose is, what about Exchange 2013? You mentioned Exchange 2010 in your presentation. Is AWS Cloud also a great option for deploying Exchange 2013? And Ulf, feel free to chime in as well.
Yes, absolutely. There is no, there are differences between Exchange 2010 and Exchange 2013. The biggest one being some architectural changes that the Exchange team has done, but there are no changes in terms of how it uses an underlying infrastructure, and with that, Exchange 2013 is equally well suited to run effectively and cost efficiently in the AWS cloud. Great, thanks, Ulf.
This next question I'll point back to Smartronix team is, can you elaborate on how to coexist, how your coexistence strategy works again? Can you be running both Exchange 2010 in AWS and Exchange 2007 on-premise at the same time? Can you elaborate on that, guys?
Yes, in fact, that's exactly what our customer that we discussed in the slide presentation did, was they actually continue to keep one Exchange 2007 server on-premise because they have a third-party application that requires that version of Exchange Server. The AWS environment is running Exchange Server 2010, and it's simply just an extension of their internal network over VPC VPNs. So it certainly is possible to have a coexistence model in place. It's no different than any other data center. You can look at the VPC strictly as just being an extension of your existing environment.
And that coexistence strategy actually facilitates online mailbox migrations. So that's part of the strategy in doing the migration is to have both environments running, and then you could do online mailbox migrations without any disruption in service.
Great, thanks for clarifying, guys. This next question I'll point back to Smartronix, and again, feel free to chime in, Ulf. How would you scale to 5,000 users?
You would scale outward, just as we discussed in the slide presentation. You would go through the same design and modeling process that you would for an on-premises deployment. You can think of AWS as just being another on-premises deployment. It just so happens to be located somewhere else, running in virtual machines atop a hypervisor. So you would take a look at your usage profile, run the role requirements calculator, come up with some candidate designs, deploy the candidate designs that you come up with, run storage validation tests against them, run load performance tests against them, and once they meet the criteria that you have, you would start moving mailboxes to it, just as we discussed in the migration steps earlier in the slide deck. There really isn't necessarily an upper limit as far as how many mailboxes you could put out there. It really just comes down to what your cost is, what your monthly runtime cost is, and how many instances you're going to deploy and support. Again, the main objective when scaling Exchange on AWS is to scale out as opposed to trying to scale upward. And that actually follows Microsoft guidance for Exchange 2010 as well as 2013. Is they're really targeting scaling outward as opposed to scaling upward.
Great, thanks, Kevin. And as we mentioned, if we don't get to your questions directly, folks, be assured that we will follow up with you after this webinar. So we've got time for just a couple more questions. I'll point this one back to the Smartronix team, and Ulf, again, feel free to weigh in. But the question is along, you mentioned that you can run Exchange 2013 on AWS, but they've introduced some new architectural elements, like basically only 2 server roles. So can you talk a little bit more about Exchange 2013 architecture kind of being effectively deployed on AWS based on those new changes?
Yeah, I can take a start here from my side, and the Smartronix team, please feel free to chime in. As I mentioned earlier, Exchange 2013 presents a perfectly viable option and highly effective option to run in the AWS cloud. The underlying architectural changes that Microsoft provides in Exchange 2013 are, in a sense, simplify the deployment model, as you really only deal with 2 major server roles. However, still, regardless of that, Microsoft still, in general, provides a recommendation of deploying combined server roles, but architecturally for an enterprise deployment, that's often done very differently, and the roles are broken out. So bottom line, the changes, architectural changes in 2013, from my point of view, only simplify things. The points of decision that you have to make around what you place where in your virtual private cloud environment are a few less than you had in the multi-role deployments in Exchange 2010. I don't know if the Smartronix team wants to add to that based on their experience in rolling out Exchange 2013 with their current customer base.
The Exchange Server 2013 database availability groups are essentially the same as they are in 2010, so there's really no change there as far as the design approach that you would take for putting 2013 on AWS versus 2010. There's also the fact that there was another significant drop in IOPS between 2010 and 2013, so that actually would allow you potentially to support more mailboxes on the same instances with the same number of EBS volumes. And then, of course, there's the fact that client access is now stateless, and that 2013 only supports Outlook Anywhere mode as opposed to Direct RPC, which is actually a much more friendly way to have your clients connect to a cloud-based service anyhow.
Terrific. Thank you, Kevin, for adding on to that. We have another question here, and Ulf, I'll point this to you, and feel free to chime in as well, Smartronix team. Are there any underlying differences in terms of running Exchange in, say, GovCloud versus regular AWS regions?
No, there are no difference in running it in GovCloud versus any other region. GovCloud besides a couple of services may not be available in GovCloud, the underlying infrastructure is not any different than in other regions.
Okay, great. Question, I'll point back to Smartronix. Can Route 53 be used for client access or regional failovers?
So the monitoring capabilities that Route 53 provides at the instance level, you can create essentially records pointing towards those instances and have a failover copied in another region. So essentially, if your primary region goes down, Route 53 can monitor the health of the access layer and fail those records over to the secondary region. There still are some manual steps on the exchange side that you have to perform to make sure those mailboxes are active. But other than that, yes, that should be supported.
Great, thank you. And I think this is a great we'll finish off with a question around, you mentioned cost and time. Can you, at Smartronix, just discuss other measurements that your customers are thinking about in terms of metrics of, what's that success of those IT deployments on Exchange look like for your customers? You kind of went through your list, but if you can reiterate that for folks, I think that is a strong case.
Yeah, so if you look at our criteria, obviously cost and time, with agility being a key component of that, are primary drivers. Again, with it being enterprise workloads, security is a key component of that too, and we look at metrics to make sure that we're compliant, that we've locked down the environment, and that the entire infrastructure is secure. But if you look at reliability, that's probably one of the main drivers. The ability to make sure that there isn't any downtime with their messaging infrastructure. As we mentioned before, and everybody knows, email is a primary collaboration tool within an enterprise, especially when you start to look at unified communications where you're talking about a messaging and video type infrastructure combined with SharePoint and Link and Exchange, all of those together. It's very important that core infrastructure doesn't go down and that you have resiliency and failover. And that's really the main metric that they want to look at. They want zero downtime throughout the year. They want to make sure that critical part of their business is up and operational, and that you can provide that kind of failover support for them.
Great, and that's a great closing point, Bob, to iterate it, that you are focused on that business critical application and keep the business up and running. So with that, I'd like to thank you all for joining us today. Again, if you've joined us sort of midstream, there's some resources available. Please connect with the Smartronix folks. Their email is up. Where to connect, I'll flip back real quick where to connect with them. There's also some white papers available on AWS, and we thank you for your time today, and I'd like to special thanks to our premier consulting partner, Smartronix, Robert Grote, CTO, Anthony Bolotegio, who's the Deputy CTO, and Kevin Brown, who's a Senior Solution Architect, as well as Ufshu, Solutions Architect with AWS. Thank you for a great presentation. Folks, before you drop off, I'd like to ask you to take a very short survey. Helps us improve our webinar series, and we do appreciate your time. And that concludes today's webcast. Thank you very much.